So I'm going to have proton NMR, carbon, and IR. And they're going to be listed out, and that is all I'm doing for experimental. I'm doing it 3 times because I have 3 compounds. And then conclusions should be like normal, but you need to talk about why or what do you know about the spectra that lets you know that that's that compound, right? So you went through and you labeled the spectra, specifically what on that spectra is a specific characteristic for that compound. So for example, I know ibuprofen has a amide group or something, which it doesn't. It's an example. Ibuprofen has an amide group. So if that's the case, this peak here is an amide signal based off this. So I know this has to be what it is. Because in the future, if you have to take organic 2, you're going to start off doing an unknown. So it's these specific characteristics that you need to be aware of to let you know that that's for this compound. So let's pretend I didn't know that that spectra was for IR or if it was for NMR, but I don't know what the compound is. So based off of these key peaks, I should know that's ibuprofen because it has this peak here that's a NH and it has this peak here that's a doublet, a triplet, example of that. So that should be what your conclusion is about. So you're not going to have like data, you're not going to have yield, you're just going to talk about the spectral features that are specific for that compound. And then you must attach your annotated spectras, all the 3 NMR-IR for aspirin, acetaminophen, and caffeine each. Now, how you want to go about doing that is completely up to you. You can print off the NMRs and you can just take pictures and upload them. Or if you want, you can just write it out on a piece of paper. If you can't print it, that's fine too. I just have to be able to tell that this peak is for this compound and this letter. So just like what we did over here, same thing. That's all I need so that you can get credit. It has to be correct. Okay, so that's what we're expecting for the lab report. I'm going to quickly go through the links. Hold on, let's see if I can do it. Let's see, I'm going to go through the links very fast so that we have an idea of what she's talking about for each one. So, let's see if I can get focused. Okay, so this is your lab number 10. So this first link right here is if you're going to lab. You're going to read it, you're going to look over it. Remember, just like you're going to lab is what you'd write your lab report, your lab notebook about, which you don't have to, but I'm just saying that's what this link is. This second link is your actual data. It's your annotated spectra that you need to write out like we did here. So it's that right there. I'm going to go through and I'm going to look at it. Hold on, this one. So this is what that link is. So you're going to go through and you're going to, so this one's, we're telling you also already, the proton for aspirin. And what you have is something that I didn't have, which I'm kind of jealous. You guys have integration. So remember, this tells you how many protons that is. So if I had a, this would have integration of 2, right? Because it's a CH2. This would have integration of 2. This would have integration of 3 because it was a CH3. This would have integration of 1. So that's another clue that can help you figure out like how many protons are in that one. So this was 3 protons, so it's for that peak there. This was 2, it could be that one or it could be that one, and then this was 1. So integration is also very helpful. So you guys have that to help you as well. So we have integration. So you're going to go through and you're going to label aspirin here using A, B, C, D, E, F, whatever you have to. And then you're going to label these peak here. A, B, C, D, whatever. So she zoomed in a little better if you need to see the doublet or the triplet. So this is the same thing, just zoomed in of the aspirin proton. Then you have carbon aspirin, and then we have IR aspirin. And so we're going to label one, I said at least 3 functional groups. So label this one, and then find another one that's similar to it. Because this one has lots of nice functional groups. Then you keep going, there's the caffeine proton NMR, and then we have the carbon NMR for caffeine, and the IR for caffeine. And then acetaminophen, we have proton, carbon, and IR. And I don't know if you talked about it in lecture, but it's important to note that specific compounds, CDCl3, chloroform D, that's a peak here, so you don't have to label it. And this one you don't have to label either. So if she has a label on it already, that's not one of your peaks that you need to label. That's like a solvent peak, and it has nothing to do with the compound. So this one has nothing to do with that compound, so you're not going to label it. Same for this one. It's the chloroform D. It's what we ran our samples in. It doesn't matter. And then same for this one at the top. So chloroform D, and then let's see, chloroform D here. So don't label the peaks that she already has labeled. That's all right. If you don't see if you see less signals than you have on your compound, that probably means that you have symmetry going on. So you need to double check, work through, and see what could be giving you signals. I think it's easiest just to go ahead and label them. So that's what that is. So first, I recommend you read the handout that she has on here, read this, and then just go ahead and annotate your data. It's going to be so much easier. And then you can type up your lab report. And you can also watch her video. She has video examples here. So this is her example of the experimental. So at this point, you should have your labels annotated. You should have your abstract written and your introduction written. Now, don't worry about putting so much information to the abstract and the introduction, because the whole meat of this is your experimental. I mean, you still have to have a good abstract, good introduction, but your main meat is the experimental and your annotated spectra and your conclusion. So she has some instructions here. This is for you to read, but your experimental is going to start off looking like this. So you have your name of your compound and the picture of it. And then you have a brief description of how she got her compound. So she also ran hers through a column. She used 5 grams of silica. She used 10% methanol. We used something else. Go back and look if you don't remember. And then she has the yield for it. I don't expect you guys to have the yield. That's okay. You don't have to have it because that was last week's experiment, like last week's experiment. So if you look, this is what you're also doing that's super important. So you have proton NMR. She ran hers on the 300. Ours is 500. So you should put 500. And then CDCl3 is chloroform D. So this is the ppm that it appears at, 7.17. She has D for if it's a doublet. 2H is the how many protons there is, so the integration. And then ARH is the type of signal it is. So AR stands for aromatic. That's the aromatic proton. If I was doing my alcohol peak, I'd have an OH. That's my alcohol proton. And then she has J coupling. So I think she only did J coupling for the proton NMR. I guess we'll keep it the same then. Sorry, I keep changing it, but I want to keep it the same as hers. So just final decision, your J coupling, you only have to do it for proton NMR and only if it's a doublet or a triplet, okay? So don't worry about carbon NMR, there will be no J coupling. And then IR, there's no J coupling, it's IR. Okay, so we have 7.17, we have the J coupling value, and then she keeps listing each of them out. And if you look, this chart here breaks it down for you on how she got these. So go ahead and read these. And then we didn't do MS, and that's what she's talking about. We didn't do the MS, so this little sentence here won't even appear for you. Instead, it'll be carbon NMR. And then we have IR. You're just going to list your 3, and you're talking about your functional groups. So this is a carbonyl. It's at 1780. And then your units will also be centimeters to the inverse. So it's the wave number. So that will be the same for you. And these are just examples of how she got those values. So your main experiment will look like this, but 3 times for aspirin, acetaminophen, and caffeine. And I think that's it. So that's what you're going to do. You're going to upload it to Dropbox, and then also take that survey if you haven't taken it, so I know who your instructor is. But I think that's it. If you have more questions or if you need me to do more examples, I love doing examples, but I don't want to beat a dead horse. So if you need anything, just let me know, and I'm happy to help.